afternoon. On behalf of Engineers Australia, I'm delighted to welcome you all to today's webinar, Thinking Green Construction. My name is Megan Purdy and I'll be your host for today. Firstly, in keeping with our custom, Engineers Australia acknowledges the traditional custodians of the country throughout Australia and recognises their continuing connection to land, waters and community. We pay our respects to them and their cultures and to elders past and present. Before we get started, I would like to acknowledge that today's webinar is being hosted with Engineers Australia's industry partner, Queensland University of Technology, or QUT. The QUT Faculty of Engineering is shaping the future by tackling global challenges like climate change, environmental sustainability, and population ageing through cutting-edge education and research. They offer students transformative, real-world learning experiences and work closely with industry partners to drive innovation and create lasting impact. With a strong focus on sustainability, inclusion and Indigenous engagement, they are preparing the next generation of engineers to lead with purpose and to make a difference in their communities and beyond. Now today, we'll hear from two speakers followed by our live audience Q&A, so I encourage you all to please send your questions through to the speakers via the chat box. I'd now like to welcome our first speaker, Robin Drogmiller. Robin is a Professor of Virtual Design and Construction in the Faculty of Engineering at QUT. He teaches in the Construction Management and Architectural degrees. He has engaged in over 40 million of research projects over the last 25 years around digital engineering and BIM in the AEC sector, renewable energy in the electrical distribution system, and weight engineering and aircraft design. He is a member of the Art College of Experts, a Queensland board member for Lean Construction Australia and New Zealand, and is also on the Brisbane Committee. So please join me in welcoming Robin Drogmiller.
Okay, thanks for the introduction. You may be wondering why I'm Professor of Virtual Design Construction is talking about Lean, but I've been involved in BIM for 30 years, and I've noticed that BIM is great for explaining and handling the technical part of projects, but there was always the issues about how do you actually manage the processes and optimise the process of working with BIM and into the project, hence this presentation. I'll be just talking about lean construction and how to think about it, and then Freshta Banakar will be presenting another presentation after me looking at lean and BIM. So the goals of this presentation, we want to demonstrate that lean thinking is nothing exceptional or demanding, and you're most probably doing some of it already. We also want you to consider which aspects of lean you already use and identify them. Then we're going to discuss how lean and BIM complement each other, at least Freshta is. And then we've got several case studies to validate the discussion. We're not just talking about theory. And we want you to examine lean more deeply and consider how it fits within your organisation and the projects you're involved with. This is a quick video done by Ken Panitz when he was at CIMIC explaining the principles.
Into value from the customer's perspective. The continuous elimination of waste and the creation of value flow with minimal waste and without interruption. In Lean, value is always defined from the customer's perspective. In this example, the truck has no value, only the product. Most within CIMIC will be familiar with the Plan, Do, Check, Act cycle, but many also misunderstand its meaning. I like to illustrate it like this, since within Lean you must continue to iterate through PDCA until you reach success, using standards as a wedge to ensure that your hard-earned improvements are sustained. Lean also teaches us to recognise that while most organisations and teams are vertically aligned within discipline-specific roles, the process is rarely contained to a single team. The flow of work or value through the organisation is often chaotic, having to travel up and down multiple structures before success is reached. Lean uses tools such as value stream mapping to streamline flow horizontally across the organisation. Lean takes a very hard view of waste, defining it as anything that does not add value for the customer. Motion, the unnecessary movements of people, waiting, time wasted, waiting for someone or something, transport, the unnecessary movement of products or materials, defects, efforts caused by rework, scrap or incorrect information, over-processing, doing it better, and overproduction, doing it more than is required by the customer, which leads to inventory, the excess of products or materials, and lastly, non-utilised talent or wasted human potential. What's left is value.
One of the concepts that Ken was talking about, the customer, can be confusing to people. With a project we're dealing with, the project client's a customer, the person who's paying the contract and the money, the project owner, if that's different, then the users of the project, and also the approval, the council, local government, and also the certifiers and so on. But one aspect that's not really recognised in this concept is we have a simple network diagram here, a little play one. The person who's doing the poor foundation, their customer is the next people in the tasks following that, the succeeding task. So they're the direct customers, and then the other three on the right, they're indirect customers. So the people pouring the foundation need to make sure their results meet the needs of the people who are going to come subsequent to them. So, and waste is any activity that doesn't add value. That was pretty clear from Ken's presentation. And when we look at the proportion of waste, analyses have shown that a lot of activities on site in the red section there shows that over 50% isn't adding value to the project. And there is the activities that don't add value but are necessary. So, for example, inspections and certification and approval of cost flow and so on don't add direct value to the customer, but they're necessary for the project. And then we have the green slice there, which is actually the value-adding activity, which we want to promote and increase. And here are some other examples of some of the waste that Ken had in the video. The project I'm talking about was originally called Driver District Centre. It's at Palmerston in the Northern Territory in Darwin. And we'll be using this as our initial case study. It's now called the Palmerston Senior College if you want to go looking at it in Google Earth. So looking at some of the background in the Northern Territory, very tropical environment, hot and humid. Many of the schools were designed as unitary buildings, which basically means that the whole project needs to go in a single stream. Damien Berger, who was an architect, was working with me in the NT government, designed the Sanderson Middle School. This was on a slight hill, and hence it was simpler and more appropriate to break it up into individual buildings. So Damien did the initial design, and then more Linklater Eric did the detailed design documentation on this project. And this actually was testing out some ideas which we then had to use when we went on to Driver District Centre. So I'll talk about the reasons for that in a minute, but you can hopefully see the similarity in these. And here are some photographs. On the bottom right is the Sanderson project, where the facade was an aluminium sheet curved in a semicircular shape with circular columns, and then the Driver District Centre had rectangular columns and glass reinforced cement fascias, just to give it a different appearance. So why are they so similar? And sorry, here's the floor plans of these, or site plans, to indicate how similar they are in concept, at least. So here's a recent photograph from Google Earth. The buildings with red circles on them weren't part of the project I was dealing with. So the constraints on this were that the budget for this project was announced in August of 1983, and they wanted handover by December 1984. So that basically gave us 16 months to complete a 700-student school, and I was working with the Department of Public Works at the time, and we had no idea this project was coming. So that was a shock to everybody, and we had to figure out how to go from basically a dollar amount and a brief to a operating school within 16 months. Complicating factor, the average annual rainfall in Darwin is over 1,700 millimetres, and that's mainly from November to March. So we had to do this project over 2 wet seasons. and it's also a cyclonic region which has extra requirements for structural, and then the project also included a cyclone shelter which had to be built with a 1 in 200 design wind speed. And then the community facilities, this was shared, the library had to be available to the public, as did the cyclone shelter, so that put constraints onto the way the project was designed. So here's the site plan. The ovals to the right, and then the two buildings with the dark rectangle around them, blocks C and D, were two-storey buildings. The ones without any shading around them were single-storey, and then the one with the red around it was the cyclone shelter. And if you look at the elevation above, you'll see the cyclone shelter isn't included on that because it wasn't even designed at this stage. All the documentation of the project was done in-house within the Department of Public Works, and then the construction was done as a contractor-led project, where the separate contracts were let for the initial excavation, the site works, and then the individual buildings. The two-storey buildings were constructed first, and then the tech studies at the back there was done because that had the plant for the project, and then the single-storey classroom and administrative buildings were next. The cyclone shelter was done last. Now, this is an example of poor planning from the lean concept, because the two-storey buildings were going to take longer to build, hence they were designed and construction was started first. And the cyclone shelter was conceived as being non-core. The school could function without it, and they were worried about access to adequate resources to do the whole project at the same time. So the design and construction of the cyclone shelter was delayed. So as I mentioned, this is an example of poor planning, where you're actually looking at when things need to be done. So we started with the date for handover and then worked back on the duration of each of these components. So the optimisations we made, the site works and the roadworks and the stormwater and the building platforms were all started before the detailed sketch designs were even finished. The idea here was to make sure that we had access to the site all the way through the wet season. So with all the roadworks and the stormwater in place before building even started, we could get continued access to each of the buildings. And because the services need to go right up to the proposed building areas, there were earthen platforms built on the area of each of the proposed buildings, with a tolerance of about 6 metres all the way around to allow for last-minute design changes. So that was to provide a smooth process throughout the construction process. So the civil projects all started in October, and the building started in around February of 85. And as I mentioned, the two-storey ones were done first, then the single-storey, and then the cyclone shelter construction only started in about October of 85. That was being designed concurrently with the construction of the rest of the school. So this is designed to break the dependencies between the different components. And then the handover was in December of 85. So the project was completed on time and on budget, even though we only had the 16th month construction period. And from memory, there was only 1 day of delay due to rain. We were fortunate that the wet season wasn't as bad as it often was, but the pre-planning and access through the completed roadworks assisted there. And then I've already mentioned the pool planning, where we took the dates for completion, required completion of different components, and then worked backwards from there to decide when the work on the design work and then the construction work on each had to start. And that made sure that all of the facilities that were required to be completed for handover were. When we're looking at the floor plans, I mentioned that previously a lot of the schools in Darwin and the top end were fully air conditioned. Damien Berger did the design here. So the idea here was to have external verandas around all of the buildings. So this provided plenty of space for the students to get around, but also meant that there was no air conditioning required for the circulation spaces. Damien had some deep discussions with the Commonwealth Government, who were funding this project at the time, because the total areas exceeded their formulae. But he managed to convince them that by following this concept, you actually had roughly the same construction cost, but the operating costs were substantially reduced due to the reduced heating and cooling requirements throughout the year. So the brand has helped there. Then we also, the wall framing, cyclonic area, you need to provide debris penetration. The wall frames were just metal C-channels with 19mm compressed fibrous cement external cladding, which provided the debris penetration. And this meant we didn't have any wet trades for the buildings other than the wet areas and some walls that were required, concrete block walls that were required for structural shear support. We also identified the prefab potential, so the facades were all done with glass reinforced cement panels. The top ones were a different shape, obviously, than those on the balconies on the two-storey buildings, but this allowed a level of prefabrication. We did have some issues with variation in size, but that was handled by sorting the facades to make sure that the lines looked uniform. And then we had the wall panels. There was a lot of commonality there, so that the individual contractors who were awarded the individual buildings, they were all attended separately, could use prefabricated wall panels if they chose to do so. Then with the stairwells, there were 8 stairwells all up with a curved shape. This was designed to allow the formwork, which was pretty expensive, to be reused as much as possible, because your formwork is 40 to 60% of the total cost of concrete. And the contractor on the Driver District Centre, because these were pretty much the same as on Sanderson, actually asked if they could reuse the formwork on Sanderson and save themselves several $100,000. Okay, the structure was very simplified. Basically, the top story and the single story, top story of the two-story buildings and the single story buildings were just steel framed, where they had the concrete column on the outside of the veranda as the provide the major bracing and structural support. Then there were 102 by 102 RHSs in the external walls, and then also underneath the ridge. So a very simple structure, very quick to put up. And then the second, I mentioned the concrete columns and steel frame. Then the ground floor was concrete columns, which was just continuous with the upper floor on the two-storey buildings, with concrete beams running through on the shortest dimension of the buildings to handle the spans. There were also very thin concrete columns in line with external walls, and also one in the middle of the building to keep the spans low. So in reviewing this, we made sure we gave value to the customer. The customers got the building that they asked for and met the brief, looked reasonable. We took great care about making sure that everything was student-proof, and we achieved that. And as I mentioned, it came in on cost, under cost and under time. The value stream, we made sure that construction process could continue all the way through the project. There was never any time where the speed of work on site decreased. And we also ensured flow, so that when there were two buildings that were butting up against each other, that the individual contractors were scheduled to actually be working on those bits separately or separate times to ensure there are no clashes. We also used the pool planning, which I've already mentioned, and aiming for perfection, maybe not, but use of the succession, where we went from single buildings that had covered everything to Sanderson, where we had external verandas, and then on Driver, the current Palmerston Senior School, we're able to optimise some of the construction aspects to make that even better. One thing about lean construction is that differentiates it from manufacturing, the other aspects of lean, is the last planner concept. And The last planner is the person closest to the work who has authority to make decisions and create assignments. What this means is this is normally the leading hand on the work gangs, or the supervisor on the work gangs who does the planning. If we look at manufacturing, you can see on the left there's a production line. It doesn't really matter whether they're robots or people in there. They know they have to stick this screw into this hole and turn it. There's not much rationale there for independent decision making. Whereas in construction sites, say on the right, you've got a fair number of people on site. Many of them are doing independent things. They need to coordinate themselves on the daily tasks, but also the weekly tasks to make sure that all the working areas are appropriately organised. So the last planner allows the people who are actually at the workface to control their activities. And when they're doing this, they follow that should, can, will, and did circle that Ken was talking about in the video. The should comes from the master schedule. We should be at this stage of construction. Then they do the poor planning at the weekly level, deciding what they can do in the coming week, which activities have all the precedent activities and resources available. Then they do the plan ahead for the week. They do the week planning, and then at the end of the week they review what they did and come up with the value for the percent plan complete. And here's the same concept. The should, the master planning and phase planning is done at the higher management level, and then the weekly can, will, did process occurs within the various work teams. And there are a whole range of lean tools. I'm not going to go through all of these, but there are lots of different methods under the lean umbrella, which you can look at and decide whether they're appropriate for particular aspects within your projects and your working environment. So advantages of lean construction. It's focused on the overall reduction of cost and waste. So it's cost effective and an efficient process of construction. The overall construction time can be reduced if necessary, which can lead to faster occupancy. In school projects, we had a fixed time we had to have everything done by. If we finished a building earlier, it wasn't going to benefit the customer. So there's no point throwing extra resources into buildings just to have them finished earlier than just sit there. So we're able to optimise the level of labour and activity on site. The lean approach also provides a deeper understanding of the process, so that this fosters issues around safety on site. People don't have to rush in order to achieve things. It also increases productivity and efficiency because people aren't under the same pressure as they can be when things go pear-shaped on a poorly planned project. And it also improves the overall project results because there's increased communication between the teams through the last planner system. And stress on workers and project management teams is reduced. And worker accountability is boosted because individual work teams, you have visual planning where the percent plan complete and progress on activities is often put up on a big board in the major area of the site office, so that each of the teams knows how they're performing and how the others are. So that improves the accountability. And that leads to increased job satisfaction because people feel as though they have more control of their daily and weekly activities. There are some disadvantages. One is that the effectiveness depends on the compliance of the entire management team of workers. And I've been involved in lean meetings where one of the team leaders basically said, I don't care what the other people have to do. I don't care about their timelines. I'm just going to worry about my team. And that really impedes the whole process. And then workers may be reluctant to adapt to the new construction methodologies and processes. So Ken in his video mentioned standards. There is a standard for lean, ISO 18404, which talks about quantitative. So these are numerical methods to improve process, and it brings Six Sigma, which can be used within lean, and also lean together in the one standard. So the key takeaways: successful projects are most probably using some lean methods, whether they acknowledge it or not. Do you formalise these methods? Do you make them part of the everyday construction projects? If you are using them or identify them, why not make them place them within a more cohesive framework? And your less successful projects may be running counter to the lean principles. So why not identify ways to deal with them preemptively on your next project? And why not strive for perfection in all of your projects? So this is a good time to finish up. LC ANZ, Lean Construction ANZ, is a national organisation that's promoting the uptake of Lean. There's a website there. So I would recommend that you have a look there and see what they're up to and learn a bit more about the Lean concepts. So that's the end of my presentation. So Freshta will be giving her presentation afterwards. Thank you.
Thank you, Robin, for your input today. I now have the pleasure of welcoming our second speaker, Freshta Banaka. Freshta is a research assistant within the Faculty of Engineering at QUT. She recently completed her PhD on the use of BIM to support transformation projects. She then worked on digital engineering on some major civil infrastructure projects. She has previous qualifications in architectural engineering and landscape architecture. She is now involved in several AEC research projects at QUT and in teaching into the construction management and architectural courses. So please join me in welcoming Freshta Banaka.
Thanks for your introduction. So I'm continuing on Robin's discussion on Lean. I'm going to talk about BIM and Lean. Firstly, introducing the BIM. The definition of the BIM depends on the one who's going to sell it. So we have building information model, the computer-based representation of a physical project result, basically a 3D model of a project. Building information modeling is the process of building that 3D model, and building information management, which is the process of managing BIM within an organization or a project. All of them are BIM, BIM, and all of them are correct. So they are working with 3D representation of a building in an organization in construction industry. After that introduction, we're going to talk about a real case study. It's a project they compare business as usual and versus Lean in two identical buildings. The result shows that that implementation of Lean were successful. They were able to increase the safety by 65%, decrease the cost of formwork and equipment quite significantly, and the productivity of wall and column, the formwork for those that have been increased. The overall labor productivity has been increased as well, and the project overall was 19% faster than planned. So this is a case study of a success of implementation of Lean. This study is presented 12 years ago. We have another successful implementation of BIM in a motorway improvement in Scotland. So again, this is something like the previous one. They compare the traditional CAD-based versus the BIM-based approach in design. As you can see, in all aspects of design, they put 5 times less effort. And so it is again another project which has been successful in implementing of BIM and shows the significant improvement that it can has on a project. This project again documented 8 years ago. And why don't we have BIM or Lean, BIM and Lean implemented in our project at the moment? We've introduced a change, and it's kind of relatively new, but not that new. And when change has been introduced, the next thing that pops up is the resistance to change. There is a quote from a politician in 1532. He says that there is nothing more difficult to take in hand or more uncertain in its success than take the lead in the introduction of a new order of things. And we are in 2025 and we still have that problem, resistant to change. That's why after 12 years and 8 years, when the successful implementation of Lean and BIM in the project has been proved, we don't have still the development and the implementation of Lean and BIM in construction industry is still not well developed. For change, we require top-down support from management, bottom-up support from staff, engagement, training, monitoring, and identification of opportunities for leverage. So there isn't any magical accident going to happen for us. We need to work on ourselves to make that change possible. And we are going to talk about BIM and Lean and how BIM is going to help Lean to speed up its implementation in construction industry. As Robin mentioned, Lean is talking about the principles and process. There isn't anything visual or visually presentable or appealing on Lean, but BIM is flashy. BIM visualize the building and all this information and all the elements of the building in a 3D model. You can see the building, you can see all these different elements in detail. It's interesting for your audience, and also it simulates the process of the construction, and also it simulates the, it's a 4D time simulation. So all of these visually appealing features that BIMs provide can help to implement Lean in construction industry as well. So we call it BIM Lean approach. So BIM brings the quality and productivity, Lean brings the value and safety, and both of them hand to hand when bring the increased efficiency in the building and construction industry. First, we're going to talk about the reduce of waste and optimize resources. Lean targets all forms of waste, time, materials, and labor. And BIM provides the digital tool to identify and eliminate those early in the design and planning stage. Lean aims to minimize waste in all forms and directly and leading to cost saving. BIM support is by enabling clash detection and reducing rework, allowing for more accurate material estimation. This is an example of a decision and its impact or effect on the cost associated with that decision. So with this power of BIM and clash detection, you can detect this issue of any clashes happening in a building and the design phase early in that design phase. And you can make the right decision and save money. And also it improved planning and scheduling. BIM has 40 capabilities, time-based modeling, and visualization, Lean has pool planning and just-in-time delivery, and both of those BEAM can help that Lean's pool planning, and it can enable more accurate sequencing and fewer delays. Combination of BEAM visual sequencing and capabilities of Lean will allow construction industry to identify a constraint, optimize resource allocation, and evaluate multiple scenarios quickly. They also can enhance collaboration and communication. BEAM is a single source of truth, and Lean encourages early stakeholder involvement. Together, they can bring transparency, reduce any misunderstanding, reduce the number of RFI, and streamline decision making. BEAM is a model, it's a 3D model with embedded data, and it allows stakeholders to work from the same data set. This feature aligns with Lean principles of collaboration and transparency, also reducing the misunderstanding and conflicts among project team and parties. Again, all of these result in more reliable scheduling, better coordinated workflow, and proactive issue resolution throughout the whole construction process. We also have continuous improvement throughout data, through the data. Lean's mindset thrives in BEAM data-rich environment. Team can analyze performance metric in real time, refine workflow through the project lifecycle. And BEAM can collect the data in a model and analyze it, and has these capabilities to feed into Lean's continuous improvement cycle. It allows team to learn from past projects and constantly refine every project stage. We call it a data-driven approach, and this approach continuously optimizes overall project quality and lead to increased productivity and efficiency at the end. And prefabrication and modular construction. Lean promotes off-site construction to minimize on-site inefficiencies or any errors or delays. BEAM also supports this within precise modeling and coordination, reducing reworks and improving quality. Design consistency and fewer error. Again, we're going back to that clash detection. And automated quantity takeout. It reduced the variability and coordination issue, while Lean also ensured that only value-adding design elements are pursued. Project delivery and cost saving. By streamlining the workflows and reducing rework, BEAM Lean approach will shorten the project timeline and also help keep the project in check. The key takeaways of BEAM Lean integration. BEAM is flashy, Lean is not, and BEAM technology can help Lean construction principle and speed up the process of implementation of Lean in construction industry. This integration of BEAM and Lean reduce waste and optimize resources using construction projects. Lean BEAM improves the planning, scheduling, and collaboration across project teams. And it also has a positive impacts on all project phase, from pre-construction, construction itself, and post-construction. Also had some real-time example shows the Lean and BEAM success in construction sector as well, so we can learn from those. And here is the Lean construction, Australia and New Zealand, which can help us to implement this principle more and better in our projects. Thank you.
Hello, everyone. Fresh Day, thank you so much for your presentation. Well, it's now our audience's turn to get involved. So I'm very pleased to start with a couple of questions that we've received from registration. But before I do, I should encourage everyone to send through your questions via the chat box. And don't forget to let me know who your question is directed to. So I'll bring Robin into the conversation again. So, Robin, I've got a question which has come through from Carvey from Victoria. Now, Carvey's question: how does lean construction methodologies specifically enable the management of task interdependencies, reduction of handoff dependencies, and the improvement of flow?
Okay, yeah, thanks for that. That actually strikes right to the core of lean or lean construction. So the last planner concept within lean construction is the aspect that allows us to take the overall project plan at the high level, take it right down to the work face, and then allow the activities at the work phase to feed back up into the overall plan all the way through the actual construction process. And within the various meetings that are held to handle the last planner concept, so the team leaders come together, say for the different trades who are going to working on a particular area of the site at that time. They have mutual discussions about who needs to be doing what activity in what place throughout the week when they're just doing the week planning, so they can then resolve interdependencies and clashes right on the spot. But then they will also be doing 2 weekly look aheads and possibly longer look aheads for more complex supply chains to also pre-consider ideas. So the idea is that people who are actually doing the work can also identify interdependencies and handle the handoff of the tasks and so on in an efficient manner. And the intention is also for them to be able to improve the flow as they're doing this by looking ahead and then looking at which activities could be ready for immediate action in the future, so that the continuous flow is maintained.
Awesome. Thanks, Robin. Navdeep from Victoria had a question which it's all about: how do you apply lean construction when there are occasional variations from the contractual work? So I suppose going back to that your answer before, how do you then plan for those variations?
Well, yeah, I'm not sure the variations are so occasional, but I would suggest that the lean actually helps in assessing variations so the client wants to make a change to the contract. Then the chain of planning within the lean approach allows you to drill right down, and ideally you'd actually be talking once again to the leaders of each of the teams who are actually going to be doing the work, and then their comments about the impacts of that variation and coordination with the other team leaders can then feed back up through the project hierarchy, so that a fairly accurate impact of the variation would be feasible, and that could then be costed and the overall project plan adapted, or the effect of that could be adapted. And if it's been done properly, you'd also be doing the risk analyses based on the impact of that variation as well. So it provides I think the potential to actually address the variations in a much more risk-averse manner.
Excellent. Thank you. Fresh Day, I'll bring you into the conversation. I had a question which came in from Fiona from Queensland. So that came in from when she registered. So hi, Fiona. The question was: in your experience, what has been the most effective way to embed lean thinking in young or new engineers so they can carry this through their career?
Thank you, Feno. And the first thing that we do is to explain the potential benefits of lean, but it's not enough. So then we bring the real world examples from guest lecturers and also the real world project implementing lean and also implementing BIM and lean tools. In some of our unit, we have some tiny techniques, small techniques. So when we are developing or designing the unit, we implement or kind of design the assignments for the course using and asking student to use these techniques for their assignments, such as this root cause analysis, design thinking to develop analytical thinking and the behavior of thinking analytically among students. These root cause analysis, as they ask, one of the techniques is the 5 why technique. So they ask 5 why question, then this question will lead them to the cause of the problem. With this method, they can kind of familiarize yourself with the problem instead of just reading the problem and then go to the solution. They need to focus on the process of understanding the problem. And something else that I personally do is that instead of assessing their assignment based on the amount of work that they do, I focus on the quality of the results. So we kind of promote value over the effort and encourage innovation and simplicity. It doesn't necessarily mean that if you produce 10 or 100 pages of assignment or submission, doesn't necessarily mean that it's a good submission because we want the result to be in high quality. So we focus, for assessing the assignment, we focus on the quality of the result instead of just the amount of work that they do. So with this approach, we'll teach them that overdoing or any task is not doesn't bring any value to you. Instead, you need to shift the focus to the process thinking and think about the process that you're going to reach the result through that process and make it efficient as much as you can.
If I can add something in there, assuming Fresh is finished. One of the things that's emerged from the application of lean into projects in our industry is that one of the concepts of the last planner is you only do the tasks that you plan for that week. So that actually reduces the pressure on the project team and leads to a much more structured environment instead of the handled by emergency approach that was much more common in the industry in previous years. So the strong use of lean and the last planner especially actually provides a more work balance environment in the industry and would potentially also make the industry more attractive for women to come into it. And when we look at the scary numbers that we see about the number of people in our industry versus all the upcoming work and the work requirements when, say, the Olympics and so on comes on stream, we need to find new people to come into our industry to boost those numbers. So if we can actually make it more attractive to women, then that's an obvious source of an increased workforce.
Exactly. That's a good thing. Well, I might pull in some of the live questions. There are a heap of live questions coming through, so big thank you to everyone who's watching. Elizabeth had the first question, and Robin, I'll direct this one to you. It is, what is the one thing that you have found in lean construction that has been on consistent value stream over the last 10 years?
Well, one of the things that has really been increasing over the last 10 years and so is actually the increased requirements around temporary works on site. So if you cast your mind back to the movie, they were pointing out that the truck doesn't add any value. It's only the load that the truck's carrying. So temporary works don't actually add direct value to what the customer's looking for, but they are necessary in order to meet new safety requirements, safety legislation, and also the push by workers in the industry for a more comfortable environment, better facilities on site, and so on. So while they don't add direct value to the customer, they help to deliver the results. So I'd say that the temporary works, and especially around safety, is the most significant change that I've seen in the last 10 years.
Thanks, Robin. Another question came in around Six Sigma. This is usually used in manufacturing to have repeatable and reproducible product through quality checking. How is it being used in construction?
Okay. Well, our observation is that Six Sigma is not being widely used in project teams within the design and construction buildings. And I think that's mainly due to the temporary nature of our project teams, where you'll have a number of personnel in a company, and then they will bring in new people and subbies and so on for new projects. So there's a lack of continuity for employees and so on, and project teams in our industry. However, the ISO 18404, which we mentioned earlier, that's the ISO standard for Lean and Six Sigma certification. Identifies that there are lots of overlaps in applying Lean and Six Sigma. So picking up some of the Lean methods would implicitly bring in some of the Six Sigma concepts.
Excellent. I have another question for you, Robin. Sorry about that. This one's from Medea, who's watching live. So a big hello to Medea. We usually go for design, build, project, delivery method in convention constructions. In Lean, what would be the project delivery method?
Well, I would say that your design build is an ideal environment to be applying Lean, because thinking back, I'm not sure I made it explicit enough in my presentation that Lean is just applicable to the design side of projects as construction, and also into facilities management. So if you're doing a design build, then the designers can actually take the advice of the construction team while they're doing the design to optimize the efficiency of the design and the construction process. And you can also take that further when you're, say, using integrated project delivery, which to my thinking, IPD is where you have a design build type project, but there is a sharing of risk amongst the participants in the project as well. So I think Lean is also a way to actually improve the performance for IPD as well as design build, because you can integrate things much more closely.
Thank you. I've got a question. Well, there's a couple of questions that I can see come through live with regards to BIM and Lean. So the first one was from Drods. How can teams using BIM and Lean work better to solve these kinds of communication delays? Ferishteh, did you want to maybe address that one?
Yes, I do. So the communication delay is not really something that a software tool can solve by itself. Using or implementing just BIM Lean is a culture. We need to improve our current culture and allow that other kind of innovation. We need to bring those innovation, which is the BIM Lean implementation, to our current culture in the industry. construction industry. So everyone needs to build this behavior of and kind of embrace the value of Beam Lean and implementation of Beam Lean. And they need to trust it. And after trusting it, they need to do something about it, not just relying on other team members. Because it's a collaborative environment and they need to collaborate with each other. Everyone are in the same boat and everyone needs to do their own task. So this boat is go forward. And so this is not something that can be solved in one day or with one tool or software. It's a culture, and we need to educate everyone and convince actually everyone that this method needs the effort from all of you.
Thank you. Thank you, because there was a question which came through from Gavin, who's watching live, who said, Freshte, who do you believe is best positioned to implement a BIM framework within a construction project to most effectively support the BIM and the Lean methodologies?
Yeah, I can say everyone, because it's not only the, as I mentioned, it's a culture, and it's not just a project, for example, project manager or team lead responsibility to implement this framework. It needs the collaboration of everyone from the design parties to the client. They need to accept this culture and let this innovation into the current workflow and their current, the current workflow of their project in industry and construction industry. So it's the responsibility of everyone to change that culture first.
Thank you. Robin, I'll pull you back into the conversation. We had a question which came through from Chan from Queensland, and Chan submitted this question when they registered for today. And it is, why do we keep duplicating compliance? So onboarding, plant checks and recertifications for the same teams and equipment across projects. From a project management standpoint, this adds time and cost, doesn't add value to the process, and goes against the core of what Lean construction is meant to eliminate.
Yep. Okay. Yeah. Thanks for that. So I'd say that the application of Lean allows you to identify those activities and processes which do not add value, and so this is a way to identify the waste that Chan has identified. So once the waste had been identified, then the methods can be applied to reduce that redundancy. And I would say that this is an area where you could also bring in the quality management principles that could be applied across an organisation. So, just to go up to a slightly higher conceptual level, we're not saying that Lean and the Lean approach is the answer to everything. When you're looking to improve your processes, you should also be looking at bringing in some of the other standards and management approaches as well, such as the ISO 9000, the quality management standards. So there are methods of working that are outside of the strict scope of Lean that can also be brought in to improve and supplement the Lean way of thinking.
Thanks, Robin. I think you answered this question before, but just to clarify, Tony asked, does Lean thinking increase risk?
I would say that Lean thinking used thoughtfully and properly would actually tend to decrease risk, because when you are getting down into the detail necessary to, say, apply last planner, you're dealing with the people who actually have to do the work, and they can identify both construction risks, quality risks, and safety risks on site. There would be other risks that at a higher level that Lean may not help you identify. But as I said, Lean's not the answer to everything. There are other areas that other methods that can be applied. But in general, I would say that Lean does reduce risk or help you identify risk, and then if you take it down to the appropriate level of granularity, you can then remove the risks as the events or activities that have the risk applied to them are completed, so that you can then reduce the length of your risk register.
Thanks, Robin. Medea has sent through a question. He's watching live. Comment. Can we say not all projects are officially labelled as lean? Many large-scale efforts are applying lean ideas like BIM, waste reduction, and collaborative planning.
Okay, now, Medea, you've actually asked a question that I didn't actually answer properly in my presentation, so thank you for that, and I'll point out to everybody else that no money has changed hands here. Basically, the whole idea of picking the project I worked on at Driver District Centre, Palmerston Senior College, was that the project was done between 83 and 85. And that was long before the first publications of Lean for Manufacturing, which was at the late 80s, and long before a last planner and Lean for Construction. So I'd actually been thinking about this project and thinking that, okay, the planning and activities for that project, the initial planning at a high level, decisions on how the project would be done, how it would be broken up, was all the sort of things that you should be thinking about with Lean, and then the way that the project is broken up to ensure that using pull methods in order to ensure that all the buildings were going to be completed on time. That was all done before anyone even thought of Lean. So I think that really reinforces your point that you may have identified, that yes, lots of projects are using Lean methods without actually even realizing it, or maybe they've looked at Lean and then picked out those areas of Lean which are going to be of massive benefit to them. So yes, you're right. Projects don't have to be labelled Lean to be using Lean methods.
Thanks, Robin. John has just sent through a question for you. Is how does value management compare with Lean?
Okay. Right. So value management is an area that I'm not quite so au fait with, so I'll answer this with a little bit of temerity. But my understanding of value management is where you're actually looking at the offerings that you're making to the client and deciding which ones provide the core value to the client, and then possibly removing those activities that aren't as important to the client. So I'd say that value management and Lean, if you're following my thinking, are actually complementary to each other. So in Lean, when you're identifying wastes, then that would be an aspect of value management. So as I mentioned earlier, there are lots of management techniques. Using Lean and value management together, I think, would complement each other. And if the value management processes can be justified through the use of Lean, then that would potentially mitigate against the perception that value management's all about just removing things that aren't important. So I would hope the value management would be considering the justifications from the Lean processes.
Thank you, Robin. There was a question which came in from Darmit from Queensland. The question was, what advances are done in the domestic market to speed up the build?
Okay. Well, there's no reason why the domestic market should be considered any differently from the major construction activities. So when you consider that in the domestic market, and you'll excuse me if I'm a little bit fuzzy with the numbers here, but I saw a presentation by AHURI, the Australian Housing and Urban Research Institute, I think it is, a couple of months ago, they stated the numbers that the number of people employed in domestic construction over the last 5 to 10 years had decreased to about a third of what it used to be. And in that time, over that period, the time to actually complete a residence had increased by a factor of 1.5 or 2 times. So don't quote me on this, but that was the general guess. There are less people working in the domestic market and it's taking longer. So I would argue that the lean approach can help in the same way, so that by using the lean planning, the last planner method, then if we can actually get work teams coordinated across sites so that you get maximum productivity on the construction sites, then that's actually going to assist the residential construction sector increase their efficiency, and then lean would actually be a clear driver for applying, and there'd be a clear driver for applying lean. And when we consider the claims by politicians that they can turn out 10,000, 20,000 houses over whatever time period, unless they actually get jobs on site, I'm not sure how they're going to do that. So we need to be looking at productivity within our residential construction area because of these issues about staffing and number of participants, and I think lean can do a long way to improving that productivity.
Thank you.
And then with domestic construction companies, design construction companies, they often don't have the same size project budgets that they can use to offset training against. So as we both Freshter and I did, we gave a link to the Lean Construction ANZ website. They're starting to offer training courses in Lean, which have a nominal cost. So there is some formal training emerging that can help both residential and larger scale contractors to start training their people in these methods. And I'm dead certain that these small investment in training by even small companies is actually going to have a significant payoff in their efficiency, and if they're more efficient, then that's going to, say, reduce the amount of time that people spend travelling. If you remember back to the wastes in lean, travelling between sites is a major drag within domestic construction. So I would think that would pay off very quickly in increased profit margins to the smaller scale contractors as well.
Awesome. Thank you. Freshter, probably I'm getting to the end of all our questions. So Freshter, there was just one which came through from Jegan from Queensland on registration. And it was lean construction over the traditional construction methods, approximate percentage of GHG emissions that can be reduced, and are there any existing supply chains to support circular economy benefits?
That was not an easy question to answer because it's not my area of expertise. This is greenhouse gases emission and the impact of it and the relevance of it to lean construction is a totally different area. But it's different. I am not aware of the studies that's been done in that field. But the thing that I know for certain is that lean involves in the reduction of waste in material, and also it reduces the waste of resources that you use. So it would be reduce the GHG emission. Yeah, that's the only thing that I can certainly answer.
Yeah. And just to refer back to my case study on the school up in Darwin, when Davian Berger, who was doing the designs, when he decided to try inverting the buildings so that the teaching spaces or the use spaces were in the core of the building, and then the communication spaces, the verandas were outside. For the same cost, initial construction cost, that was going to have a significant impact on the energy requirements for the air conditioning of buildings, and Darwin requires air conditioning almost the year round if you're going to be comfortable. So that would have been a significant saving in greenhouse gas emissions. I wouldn't have any idea on the numbers on that, but that gets back to the point about lean applies as much to design as to construction. So by taking the lean thinking, looking at alternative approaches and assessing them, in that case, led to a significant long-term saving to the territory government.
Thanks, Robin. Look, I think that's all the time that we have for today. But what I might do, and I haven't told the speakers this, but if they have any, I suppose, final comment or a key takeaway that they would like to leave with you, the audience. So maybe, Robin, did you want to kick off?
Yep, I'm happy to do that. Well, as I just mentioned, I think lean is applicable all the way through the entire procurement chain for in the construction industry. It should be considered right from the start of a project all the way through to handover, and then also looking at the operations involved in the continued maintenance of a project. Just to bring an entirely new case study at this late stage, there was a building I saw designed in Townsville where there was the air conditioning plant on each floor. The plant room was designed with a hatchway so that when they needed to take the coils out of one of the pieces of air conditioning plant, they actually just removed the hatch, and then that hatch then the coils could be taken right out into what was normally part of the corridor. So there was an efficiency in the long-term maintenance of the buildings as well, because there wasn't as much space required to service the air conditioning plant. So that flows all the way through, and if the designers hadn't thought of that, then there's no way in the world that the facility managers could have done that. So our lean applies everywhere through our procurement chain. I think training your staff is going to have significant payoffs, and I think to pick up on Fereshta's presentation, there are also some significant potential savings in the use of lean and BIM together in order to increase our overall efficiency.
Thanks, Robin. Fereshta?
So as I mentioned, this BIM lean implementation is not a new approach, but it's not well known and well implemented yet. It needs a cultural change, and it needs us to all embrace this innovation and its new changes. And without that, us allowing us to change, there are no efficiency. There's an implementation of BIM lean in our project and construction industry, and there won't be any efficiency bringing with that method because we haven't accepted the culture yet. And we need to accept that culture and change ourselves first, and then it can bring value.
Awesome. Thank you. Thank you both. So I think that is all the time that we have for today. So please join me in once again thanking our speakers, Robin Drogmiller and Fereshta Banakar, for their time and input. I would also like to thank Engineers Australia's industry partner, the Queensland University of Technology, or QUT, for their support. I am very pleased to share that Engineers Australia's Excellence Awards actually the nominations are about to close. So we look forward to seeing you all attending the local events, which will be happening in September. It'd be great to see you at that celebration of excellence. And then if you don't mind, please completing the short feedback form, which is linked in the description box below. By completing that, it really does help us to improve and plan for future sessions. So finally, thank you again for joining us, and we hope to see you at our next Industry Partners event. Good afternoon.